Compound is long term. It literally, the interest that you pay per month is not the consistent same. It actually gets larger if you don't pay it back. So your interest is it's in your own interest to pay back ASAP, generally. Okay? All right, here we go. How do we do this? So this is a recurrence formula for a sequence that is what we would call a geometric. Notice here, it's R times Vn. You see that it's a times, and you notice that the R is a bit different. And I usually will explain to you why this comes about. You're just going to memorize it, okay? If you want to know where this comes out, I can show you why the rule is as it is. But this is what they're saying. You start off V0 is the initial amount you borrowed, or the amount that you have. So that's your principal. And then this is your recurrence formula. The next value is based on R, which is calculated as 1 plus R over 100 multiplied to what your nth term is. So R, which is 1 plus R over 100 multiplied to Vn. I haven't taught you the rule so that you can calculate, say, over 50 years or something like that. Right now, you're going to be doing on your calculator one entry at a time. Kind of like simple interest, where in Ex8E, you did one entry per entry, right? So I'm going to do an example for you as you're copying these rules. This is what you need to know. So Vn of plus 1, to find how much you owe per year on a compound interest, this is how much you start off with. So V0, this is the rule that you're going to be working with. Okay, and then for those who are interested, I can then show you individually why it's 1 plus R over 100. For those who just want to know how to do the questions, then just watch on what I'm doing. Okay, so just copy that down, because that's going to help you understand how I'm going to do the next question. Okay, and we're going to do it on our CAS. I'm just going to open up my CAS first. So just get prepared. There we go. Copy down the recurrence formula. So recurrence is just the idea that you're repeating the same steps over and over. A formula, on the other hand, allows you to predict. Recurrence is simple to understand. The rule is generally harder, but it's easier to calculate for long term. So if you wanted to predict for the 100th year or the 100th month, how much would you owe? You can calculate with a rule. This one's not a rule. This is literally just a pattern for your sequence. Okay? Here we go. Let's have a look at the question. So hopefully you've copied down the rule. If you haven't, I'll refer back to it. But here we go. This is an example of compound interest modeling. Okay, so here we go. This is what it looks like. It says the following recurrence relation can be used to model compound interest investment of $2,000. So think of it as you have $2,000 and you want to put it into an investment, right? It says you are paying an interest at a rate of 7.5% per annum. Per annum means per year. 7.5% is your R. That's your little R. R equals to 7.5. That's your rate, interest rate. In the first part of the question, they ask you to use the recurrence relation, so what they've given you up there, to find the value of the investment after 1 year, 2 years, and 3 years. So how do you do it? Here we go. You start off with V0 is $2,000. You want to find V1. If I follow the formula, it's V of 0 plus 1. That's how you get V1. That should equal to 1.075. So they already gave you the 1 plus R. They've already done that for you. You'll see what I mean once I break it apart. Times V0. Okay, so I'm just using, if n was 0 and this was 0, then V1 would equal to 1.075 times V0. Now, for those who are wondering where the 1.075 came from, this part came from R, and remember R, if you've copied the notes, it was R over 100 plus 1. True? So 7.5% is the same thing as writing 7.5 over 100 plus 1. 7.5 divided by 100, if you do that on your calculator, is 0.075. That's where they got 1.075. Okay, so you're relying on the interest rate they gave you. So you started off here. They gave you 7.5% per annum. If you applied it into the formula that you had over here, so this is R. If you applied 7.5 over here, That's how they got 1.075. That's where they got it from. Okay? Now, I've got my rule. What do they want me to do? They wanted me to find V1, for 1 year, 2 years, and 3 years. So I still need to know what this equals to. So on my calculator, I'm starting off with 2,000, and then I'm multiplying 1.07 to the amount I started off with, which was 2,000. So here's my calculator. Let's do it. I'm going to grab out my calculator, and we're going to do it just on the side over here so you can see. Here we go. I'm going to zoom out so you can see my calculations. The calculator, I start off with 2,000. So this is the long method. This is the recurrence method. You type 2,000, press enter. So I start off with 2,000. What am I going to do with that? I'm going to times it by 1.075. I press enter. So this is my rule. I get, after the first year, is $1,150 extra. Okay, so I now have an interest of 2,150. This is after V1, which is after 1 year. V2 would follow the same idea, that you would now take 1.075 times the previous one, the value of the previous year, which is V1. In our case here, V1 is equal to 2,150. So on your calculator, you literally just press enter again. See, I don't have to do anything. Once I've got the rule, I press enter. That's my V2. Notice I haven't changed my calculator settings. I'm still in my methods calculator settings. If you're doing methods, keep an exact value. If you're doing further, make sure to change it like I am right now. Change the settings, document settings to approximate. Okay, because in further we often use decimals instead. So I'm going to do it again. So it should be $2,311.25. Now, can you already see there's a difference in simple interest and compound interest? See, if it was simple interest, you would have said, start off at 2,000, and I add on an amount that would have been, say, 150. That's how I got from 2,000 to 150. But if I add another 150, I would only then have 2,300. See that $11.25? Compound interest allows that to happen. So you imagine on a larger scale, if it wasn't $2,000, but it was $2 million, that's going to be huge. It's not $11.25. It would be maybe $11,250. That's huge, right? So, not 11 actually, it's probably much less than that. But the point is, the percentage on a larger scale, compound interest is so good because you pay more and the bank loves that. They use that money to loan someone else and they use that interest to loan someone else. And it becomes like this massive accumulation of everyone's pulling the money together and they utilize it. Okay? So, here we go. If you want to find V3 now, same thing. So we've got year 1, we've got year 1, we've got year 2. To find year 3, on my calculator, press enter again. Oh, sorry. Very quickly. Here we go. So this is my year 3. So I've just pressed enter for each one, year 3. So that's 2,000. So V3 now, if I were to write it down, this would be V3 equals to 1.075 times whatever V2 was. V2 was $2,311.25, which now gives you $2,484.59. Or if you round it up, that's about it. Yeah. So those are your first 3 years. Now you see the problem with this recurrence rule is that if I asked you to find after 20 years, what's the value? You don't want to be sitting there to go, all right, let's do this. Let's go. That's 5th year. Sorry, that's 4th year. 5th year, 6th year, 7th year, 8th year, 9th year, 10th year, 11th year, 12th, 13, 14, 15, 16, 17, 18, 19, 20. That's my 20 years. That took a long time. If I said 200th year now, are you going to sit there and press enter 200 times? You don't want to be doing that. There has to be a better way to do that. And that's what you find in the next few exercises. There's a rule that allows you to calculate the nth year. And that rule comes from the fact that this is a geometric pattern. You're timesing. See, the pattern is that you're always timesing by 1.075. You're timesing by 1.075. You're timesing by 1.075. This is a indices problem. So if you remember back in year 7, a times a is a squared. a times a times a is a cubed. A times a times a 4 times becomes a to the power 4. The rule, if you want to calculate this, I'm going to quickly show you on the side and you can copy this down. The rule is very simple. It is still value of n, so whatever n you're looking for, it's v naught times 1 plus r over 100 to the power of n. That's all it is. And that power of n was what I was trying to describe to you. A times a is a squared, a times a times a, so the third year, you're just cubing it. So in this case here, if I wanted to find v of 20, you see, it was actually easy. All I had to do was, I start off with $2,000, I times it by 1 plus the rate, which is 7.5 over 100, that's your interest rate, to the power of 20 years. That's all you have to do. So if I type that on my calculator right now, I'm hoping that I pressed the right amount of enters, I should get the answer. So here we go. We're going to do 2,000 times 1.075 to the power of 20. Look at that. I had to do 20 enters to get 8,495, yet now I got it in one sentence. That's all mathematical. It's logical. So you can calculate. That's how your mortgages will be calculated. It's based on that. You usually do a 30-year loan. The interest rate is not 7.5. Used to be. At one point, my parents, their interest rates were 18%, so that was huge, right? This case, we're now working out interest rates are coming back up, but that there is your interest. 1 is 100% of how much you need to pay. 7.75 there, 0.075 is the amount of interest you're adding on. So you're adding on 7.75 of $2,000 and you're compounding that over 20 years, and that compound is a geometric, means multiplication. And multiplication is bad because it exponentially grows. Whereas if you're doing simple interest, it's nice. If it's $50 for the first year, great. Next year's $50 again. But in compound interest, that's not true. It goes 50 and it could be like $55. And then from 55, it gets larger. Because you're doing 50% of the amount, and then you do 50% of the next amount, and then you do 50% of the next amount. You're not relying on just the first initial amount. That's why it's called compound. Simple is easier. Okay, we like simple only when it's short term. Yeah, that's what banks would like. They would like it in short term. Long term, that's your rule. Okay, so copy that rule if you like, but eventually you're going to learn that anyway. That's in the next few exercises, but I just wanted to show you the logic to what you're going through. Compound interest versus simple interest. Okay? Now, the first exercise, you can work out the values and all that. You got appreciate, so you grow the amount, so you either owe a lot or you gain a lot of money through interest, or you can lose. If you buy a car as an example, that's $30,000 in general on average. There will be a depreciation, which means it drops in value over time. That could drop over simple interest, but usually it drops by a percentage. And that's where you use compound interest and you can work out the depreciation. That's what these exercises are doing. They're teaching you how it can grow and how it can lose. Now, how does it lose? The only difference in your formula, if it loses, is instead of timesing it by 1.075, if you're losing, it'll be less than 1. So say you're losing 10%, then it would be 1 take away 10%, which is 0.1. So that actually works out to be 0.9 to the power of n. Okay, so it'll be 0.9 compounding. That's what you'll be doing. So that's the difference. You'll find that depreciation, it's not 1 anymore. It'll be 1 takeaway. So if I go back to your rule, just to help you understand what I'm saying, I'm just going to go back and open this one up. See how this is plus? Plus means you're gaining. You're adding on that interest. It gets larger. If you want to show a depreciation, you just do 1 minus the rate. Then it depreciates. So if you add, it grows. If you subtract, it goes down. Now, one last thing for today's session. So hopefully you got an idea of compound interest. In this next question, students find this somewhat trickier only because the idea of the word compounding. You see, traditionally, and I guess conventionally, we always compound every year. What does compound mean? Compound means when do you charge them? When do you actually do the calculation? If you say yearly, that's good. Because that means, how I said every time you do as an example, just so you understand what I'm saying, if you had $100 in your bank account, okay, you put it into the bank, and I said the rate is 50%, right? 50% of 100 equals to $50. Let's say that's the interest rate. In the first year, you will get 100 plus 50% of 100. Great, that's simple interest. But then in the second year, you see it's not an extra $50 again, it's not $50 again. They're now doing 50% of your previous. So it's $150 plus 50% of 150. That's why it gets larger and larger. Now what's interesting here is that the number of times you compound it, so that's after a year. 1 year you compound it. Second year you compound it. That's 365 days of difference. The faster you compound something, the larger or the quicker the amount goes up. If you compound it every day, imagine every day you get charged. It's almost like me saying, if you don't pay me my money back after a year, I'm going to increase the amount you owe me. That's great, that's over a year. But if I said to you, every hour that you don't pay me back, you owe me $1. That's huge. Every hour, there's 24 hours in a day, you would owe me $24 if you didn't pay me back on this day, every hour. Then the next day, that's $48 in total. So compounding can change depending on when do you charge them. Do you charge them every day? Do you charge them every hour? Do you charge them every year? So yearly is ideal. Quarterly and monthly, this is why, have you noticed that that's why the banks will say monthly or not? You would prefer long. You would prefer that it's compounded over time. But normally, in general, it's yearly. In yearly, that's generally the amount of times that they're going to compound it. Okay? So, how do you calculate this example? Let's do it together. I'll show you how it works. Brian borrows $5,000 from a bank. So here we go. We've got $5,000. He starts off borrowing $5,000. He will pay interest. So this is how much he's going to pay back. A rate of 4.5% per annum. So that means the rate is 4.5% every year. Okay, annum means year. That means yearly. Which is great. So it means every year they will then get charged. So here we go. Let Vn be the value of the loan after n compounding periods. So that means in 1 year, if you only get compounded yearly, how many times does the price change, or how many times does it go up? In 1 year, if you get compounded yearly, how many times will you be charged? That's probably a better way of describing it. Once, because it's yearly. But then if it's monthly, how many times would you get charged in 1 year? 12, which is bad because that happens multiple times. And then quarterly, how many times does it happen quarterly? 4. Very good. So here, how does it change? This is what you would do. So here it says, write down a recurrence relation to model the value of Brian's loan if interest is compounded yearly. The only difference here is you start off with V0. How much did you start? $5,000. Next one in A. We know that Vn plus 1 is equal to the rate. So remember R times Vn. That's the rule that I asked you to copy down. R is 1 plus the rate over 100 times Vn. The Vn that we're starting off with is the initial. So here we go. I've got 1 plus 4.5 over 100 multiplied to V0, which I know is $5,000. This is to find out V1. So here we go. This is now 1 plus 4.5 over 100 times $5,000. This is to find V1. But like you said, this only then compounds once in the year. So this is my recurrence formula for 1 year. If I had to simplify it, this would be 1.045 multiplied to 5,000. Okay? Now, if we want to calculate this on a quarterly basis and a monthly basis according to the rule I gave to you before, okay, Remember that rule I gave to you just now? Where you can have Vn is equal to V0 multiplied to 1 plus R over 100 to the power of n. The rule, you can actually calculate any quarterlies. You can say the 5th quarterly or the 6th quarterly. In a year, you can actually calculate those simply, say quarterly. Quarterly. It would be Vn equals to V0 times 1.R over 100. Now instead of n, since n is the number of times you compound it, you told me in a year, how many times does it get compounded? 4. So if n is 1, then you would say 4n. So if n was 0, you don't compound it. In 1 year, it gets compounded 4 times. So that's why it's 4 times the amount of n. That's the number of times you're going to get compounded in a year. If it was 12, where is it again? If it's monthly, then you would compound it 12 times. It would be 12n. But be careful here. This is where you have to read the question properly before we change that rule. Notice when they said here, 4.5% per annum. So that means you only get charged 4.5% in total after 1 year. So if 1 year it's 4.5%, then how many, in terms of months, each month, how do you calculate how much of a percentage it should be per month? Divided by 12. So here, you're trying to calculate the interest rate to make sure that R value is going to be representative per month. Otherwise, when you times it by 4n quarterly, that percentage is wrong. It's not 4.5 anymore. It's now 4.5 divided by 4. This here, if it was monthly, and that was meant to be 12n, then it should have been 4.5 divided by 12. So just be careful of that if you're calculating per compound. That's what most students struggle with when they're thinking about compounding. Because not only does the number of times you compound it change, the rate changes as well. Because the rate said it's every year. But you don't keep 4.5% every month. It's 4.5 divided by 12 every month. If it's every quarterly, then it's 4.5 divided by 4 every quarterly. Okay, so that's where you have to be careful of the number of changes, the number of compounding, and then number of rates. This is to be able to do predictions. So if you want to predict for the 10th year, you don't have to do the V1,